Hello everyone, welcome to the electromechanical devices course. In this video I'm going to show you how we can build a MATLAB code for solving RL and RC circuits. Also how we can, which would be described as first order ODEs, also how we can solve RLC circuits that would be described using second order differential equation, which is the circuit equation as we discussed before. So the focus is just showing you how we can use MATLAB for doing analysis for these electrical circuits as it will be explained in this video. Solving ODEs, which are the ordinary differential equations using MATLAB. Okay. So we said that in case that would have RLC circuit. RLC stands for R resistance, L inductance, and C, this is the capacitance. This is the R for RLC circuits. We said that we're gonna end up with a second order ODE, right? And this second order ODE, we explained it with this form, like it was like L. This is the inductance, the second derivative of the current with respect to the time by dt square. This is going to be second order ODE since we are interested in finding the current. If we are solving for the current by dt, and this is going to be the 1 over c I of t equal the dvs of t by dt. Make sense? So if we are already solving this equation in the current, this is going to be second order ODE. But if we're already solving this equation for the voltage, this is going to be, we're going to deal with it like first order ODE as we explained before. The other type for this electrical circuit, for this second order ODE, we said that we can convert this one using some other parameters, like this parameter. We can write this one as the second order derivative of the current with respect to the time square plus 2xi omega n di of t by dt plus the omega n square I of t, right? And we said that this omega n, it is like natural frequency that describe how fast this current is going to change, as I'm going to show you today. And with the xi, this is like describing the decay in the current over time. Okay, and we define this xi and omega n in terms of the C and R and L of the given electrical circuit. We define that omega n, it should be 1 over CL, and the square root of 1 over CL, and the xi, we define this one by the R over 2, the square root of L over C, and the f of t, which is the forcing term, the right hand side, it should be 1 over L, the dvs of t by dt, right? So this basically how we are, these are the equations. This is the circuit equation for RLC circuit, which should be described as a second order ODE as long as we're already solving for the current. And these parameters, the natural frequency, the forcing term, in addition to the the xi, this how we defined them before. For the case that we do have just R circuit or RL or RC circuit, it means that we are excluding one of the elements, so we shall end up with a first order ODE, And we distinguish this or split it into two cases. Like basically we do have two scenarios here. For the case, or generally this first order ODE, we can write this one as di of t by dt plus the 1 over tau I of t equals the forcing term f of t. This is the general expression of the first order ODE for the current. But we do have two scenarios. In case that we do have RL circuit, for RL circuits, it means that for this circuit there is no capacitance. For this circuit, the C equals 0 or tends to infinity, as we discussed the previous meeting. So this tau, which is the time constant, this tau is coming in at the time constant, this is L over R, and the forcing term, it should equal to the Vs of t divided by L. This is the forcing, this is the voltage source, this is the inductance, this is the resistance of the electrical circuit. And for the case that would have RC circuit, it means that there is no inductance, there is no inductor. L equals 0 for this case. So the tau, it's gonna be R times C, but the forcing term is gonna be 1 over R, the time derivative of the Vs with respect to the time. Okay, so these formula, these equations, you have to acknowledge them, you have to remember them all the time. Okay, so this is generally speaking, if we are talking about any RLC circuit, it should be second order ODE. For any RL or RC circuit, it should be first order ODE. And then we discussed previously how we can solve analytically these equations. Now I'm gonna show you how we can solve these equations. How we can solve this equation using MATLAB, and how we can solve a first order ODE using MATLAB. This is the main function that we're gonna use for MATLAB, is named as the dsolve function. This is the function, the MATLAB function that we're gonna use. It is called dsolve function. D stands for derivative. Solve, this is just the solve function itself on MATLAB. Okay. So how it works, if you just open the MATLAB file, this is the main window that you should see. So once you run MATLAB, this is gonna be the first window. This is the main window of the MATLAB that include lots of functions. MATLAB is just not, it is not just doing calculation, it do so many things, right? So this is the main window, which is the command window. You can do everything through this one. This is like the debugging tool. Like if you give any instruction, like typing anything as what I'm doing here, and press enter, you already informing MATLAB to perform a specific function, whatever it is, okay, based on some statements and some coding things. So this is the main window, this is the command window, this is the essential thing in the MATLAB. This one is the current folder. For example, if you're already opening file from the desktop or the location, so this is gonna show you the location of this file is, and the other file that already included within this folder, this directory. Okay, this is the workspace. This workspace should include all the variables that you defined within the tool. So since I'm using MATLAB all the time in my research and other things, so for example, in the last run, these are the results of a raster. These red things indicate that there was an error in the coding that I already typed, okay? But these are the parameters, like I defined a variable. This variable is I, and this I is already assigned 201 value. And there is another variable which is J, it has this value and so on. So it means that any variable that you define within your code, it will be represented or shown here, and the last assigned value will be given or represented here as a value, okay? So basically we don't give care to these windows except this one in the middle, the command window. You can type anything, like you can do even the simple calculation like 5 plus 7 and press enter. So it's gonna give you the answer as 12, okay? Can you see the typing, or should I, okay, let me increase the font a little bit. Okay, where is the fonts? Customize for the command window. Let us make it like, okay, 25. And for the editors, let us make it 25 as well, so you can see what I'm talking about, 20. Now everything is very clear, right? So for example, if you type anything like 8 plus 4 and any operation, the cosine, one of the things in MATLAB that the cosine in MATLAB, the angle, it should be written in radian, not in degrees. Like for example, if you are interested in the cosine of the 30 degrees, so it should be 30 times pi. Pi in MATLAB, it should be written as pi divided by 180. To convert the degrees, which is 30 degrees, into radian by multiplying times pi by just pi over 180, and press enter. So you're gonna end up with the cosine of this value, right? So any simple calculation, you can do it very quick. This is like a simple calculator used through the command window. But if you decided to write an M code, MATLAB code, it is known as M code or generating M file. M stands for MATLAB, okay? If you decided to build a MATLAB code, you have to open an editor window. What is the editor window? You're gonna find it here. If you just press on new, you're gonna find here new script. Okay, this new script is gonna open a new script file. Then you're gonna type some coding here, right? But the code that you're already typing here, it will not be debugged. It won't gonna be run unless you press run. If you press run, you are asking MATLAB to perform all of the instructions that you give him through this window. Okay, so this window is known as the script file or the editor file, as already that would be showing up there, right? So this is the coding thing that you're gonna type code. So what is the tip? I can type this code directly to the command window, but if you type a code here to the command window, you aren't gonna able to use this code one more time, another time. You have to type it again. But if you decided to build a code and you have to use, and you are planning to use this code multiple times, it is advised to use the script file. Because the script file, you're gonna save this one into your hard disk. Then at any instant, you can run this code directly. You can debug this code simply, okay? As what we're gonna do right now, okay? Also, there is, as you can see, there are lots of things that I've done before through this command window. So it includes lots of data, right? So if you would like to clear the command window to make it blank, like you reset the command window, you're gonna press CLC. If you press CLC and press enter, you're already clearing the command window. But if you're gonna look to the workspace here, all of these variables are still there. If you would like to clear also the workspace, you have to type clear all. Clear all, it means that you're gonna clear all everything. Any stored variable. So let us work first with the first order ODE. This is the equation that we are interested in solving, this one, using MATLAB, okay? So how we can solve this one? We need to set up a code here. So this code, you can set up the code the way that you want, but I'm gonna give you one of the things or one of the approaches of building a code. What I usually do, I start with clear all, just to make sure that from any previous run, there is nothing is already saved as a variable, like clearing all the variables, resetting all the variable, okay? Because probably if you didn't type clear all, you may have a variable that was assigned a value from a previous run, and this value would affect the result of a new run. So you're gonna end up with a wrong result. So it is advised all the time, the first statement is just to clear all, to reset all the variables, make sure that all the variables assign zeros, empty the variables, then you're gonna build the code, okay? Then the CLC just to clear the command window. These like two different things, what I used to define. Then I used to give some instructions. If you pressed this % symbol, you can type anything, but this thing is like a comment. What does it mean, comment? Comment, it is not an order. It is not a statement in the MATLAB. If you type anything that is already shown green, but if you remove this %, it will be just black, right? So with respect to MATLAB, this one, it should be an instruction. So MATLAB gonna read this one and start to perform something based on what you already typing. You got my point? But if you added in front of it the % symbol, this one, it means that this is an instruction to the guy who's gonna read this file, but MATLAB won't gonna see this line. Like this line is a blank line with respect to MATLAB, is nothing with respect to MATLAB. You got my point? So this is like you giving a comment, you giving an instruction, Okay, how you can write this one, make any statement as an instruction or a code, you can just add the percent symbol in the start of this statement, or you can directly, there is comment icon here. If we just open this one, you're gonna find the comment. Do you see this percent? If you pressed on it, you're gonna convert any statement like this one. I can convert this one into comment. So MATLAB gonna read this one, but it's gonna skip this line. Line 2, MATLAB won't gonna read this line. It is like this line to MATLAB like line 3. It is blank. Make sense? So what I used to do, as I said, is just to start with clearing all CLC, then I define some. You have a question? Then I'm gonna type some, like some instruction just for myself or anybody anyone else who would use this one for after me. Okay. So for example, I'm gonna say that this code is for solving RL and RC circuits through, for example, this is like first order ODE. So let us assume that we're gonna work on RL circuit, just RL circuit. Okay, so again, these green things, these are like comments, instructions to the guy who's gonna read this file, but this is not an instruction to MATLAB. With respect to MATLAB, these lines are blank lines. MATLAB won't gonna read them. Okay, then basically for any coding, if you did like, by the way, if you did double percent sign and space, this like you already splitting the code or this window into multiple parts. Like this is the part, and I'm gonna use this part, for example, like inputs. So all the inputs will be defined within this section. So this is like a section in this code. And again, this green line, it is nothing for MATLAB. Okay. So basically, generally speaking, any code in terms of programming, whatever you already programming using MATLAB or C# or C++ or Visual Basic, any programming language, the general concept is the same, that we have to start with some inputs and there should be some processing things in the middle, then there should be outputs. Okay? Like it is like you're already solving a problem. It means that you should be given data. These are the inputs. Then you have to do some calculations in the middle. Then you have to give me an answer, right? Which should be the output. The code is typically the same. There should be inputs. There are some calculations, and there should be some outputs. Make sense? So now let us focus on the inputs. And our interest is to solve this equation. So what do you think of the data that it will be given to you in the problem? If I give you a problem of RLC circuit, what should be the data that should be provided to you to solve this equation for the current? What should be given to you? The current is the unknown. We are seeking the current value. But the time constant, I won't gonna give it to you as a time constant. I'm gonna give you electrical circuit. So the electrical circuit will be given to you in this form, right? It will be just resistor and coil, L and R, and definitely I'm gonna give you the VS, the voltage source, right? So these are the two inputs, the three inputs, the three things that should be given to you, right? Once if I give you L and R and VS, you can simply substitute into this equation to calculate tau, substitute into this equation to calculate f of s, then you're gonna plug here to calculate the current. Once you obtain the current, this is gonna be the output, right? So the inputs here, for the case of RL circuit, the inputs will be three things. R and L and VS, right? And the calculations part, it should include the calculation of tau. How much is tau? How much is the f of t, right? These are the two things that we already calculating here. Then the output, also the current equation, which is this equation. Like this equation, it should be written as di of t by dt plus 1 over tau I of t equals f of t. So these are the three calculation things. Then the output, what should be the output? The output, it should be the current function, right? So this is how we are going to build the code. We start from the inputs. The inputs are three things, R, L, and C. So you're gonna define R equals. Then you have to put the value of the R that is already assigned to you or given to you. You got my point? Like for example, R equals 10 ohms. And if you added semicolon after the statement, this semicolon, you're already telling MATLAB, don't show this operation or the result of this operation in the command window. The command window, which is this one. Like for example, if I removed this semicolon, if I run the code, now I didn't use any semicolon. So if you're gonna go to the command window, you're gonna see the R10. You're gonna see the result of the operation itself will be represented here. But if I added semicolon and tried to run the code, the command window will not represent this operation. You got it? So if you would like to stop presenting any operation through this code, once you run the code, you have to add semicolon. Make sense? So going back here to this equation, so the inputs, it should be R. We assign value for R, another value for L, let's say like 5 henries, and then we're gonna assign value for VS. Let us consider VS, it is a function of time, so it's gonna be like VS equals 10 times the sine of time. It should be, you have to add the asterisk here, sine the 2 times t. Okay, and semicolon. So t, this should be the time. It is a variable, but we didn't assign a value to this variable. So before typing this t, you have to tell MATLAB, now if I run the code, I'm gonna get an error. I'm gonna show you how this error is. But if you remember, we defined the forcing term as this is the magnitude of the voltage, and this is the function of the volt, and this is the omega. This is works like the natural frequency, the omega, the forcing frequency, as we discussed before, and this should be the time. So if I try to run the code, in this case, I already got an error. Undefined variable or function t. There is no function that or variable that you define t. I didn't define this variable before. So it is something weird to MATLAB. So how you can assign value or define a variable, you can directly assign, like here I'm defining R as a variable, but I assigned a value to this R. I defined L as a variable, but I assigned value to this R, to this L. I defined VS as a variable, but I assigned to it a value. But the one that you didn't define it or even assign its value is T. So, but we need T as a variable because we're gonna do derivative. Into this equation, we have to do the derivative for the force. For the forcing term, here we're gonna use the VS as it is. But for this one, for example, we're gonna do derivative with respect to the time. So we need the variable T as a symbolic variable. To define a symbolic variable, you're gonna type SYMS, which stands for symbolic symbols, right? Variable. And space, and then you're gonna type the variable name, which is T. So now MATLAB understands that this T is a symbolic variable. So if you decided to do derivative, integration, assign value to this T in any other later statement, you can do it. So now if I run the code, I won't gonna end up with any error. We run the code, we perfect. Even VS, if you type VS, you're gonna end up with the value of VS that you already assigned to to this variable before. Make sense so far? Question?
Yes.
Okay. Also, one of the things that we basically need to define in the inputs is the initial condition. If you remember, when we solve this first order ODE, we're gonna end up with the current, and the current will include in the current function that the final results, there should be a constant, right? And this constant, to find it, we have to substitute some initial conditions. So that's why for the first order ODE, we need only one initial condition. So let us assume that this initial condition is I0. So I'm gonna define here in the MATLAB code I0 as initial condition. Then I'm gonna assign it a value. This initial condition, it would be 0, 1, 2. This is like the initial value of the current. Assume that we start from 0. There is no initial current in the electrical circuit, or there was like 1 ampere in the electrical circuit or 10 amperes in the electrical circuit. It depends on the given initial condition. Make sense? So all of these are the inputs, nothing more that we need. Okay? You can put some instructions in front of each one of these. Like for example, if you type percent and you gonna type resistance. So what does it mean? You're just telling us that this variable is a resistance. What is this R? What does it mean R? This is resistance. What does it mean L? This is inductance. And again, these green things, these green instructions, these with respect to MATLAB are nothing. MATLAB just gonna read L equals 5, semicolon, and that's it. But the percent inductance, MATLAB won't gonna read this statement at all. What is this thing? This is the voltage source. This is the voltage source. So you can add some comments in front of these things just to tell yourself what are these variables. So this is the initial condition. Okay. So this is for the inputs section. Now let us move to another section. So double semicolon and space. Then you're gonna have, let us move to the calculations section, the second section. So in the calculation section, we have to calculate some things, some variables here. The first thing that we have to calculate is tau, also the forcing term. Then we're gonna substitute into this equation to solve this equation, right? This is what you even gonna do if you decided to work by hand to solve analytically, right? Okay, so let us define here tau. Okay, so let us define here tau equals, according to this equation, we're already solving the first order ODE for RL circuit, for just RL circuit. So for RL circuit, which is this one, tau, it should be L over R. We define for RL circuit tau, which is the time constant, there should be L over R. So we already got L. We assign value to L as 5. We assign value to R as 10. So this should be L over R. Very simple. And semicolon, this is the tau value. What next? We do have the force. So we're gonna define F, stands for the force, for example. F equals, the force, it should be Vs divided by L, right? And semicolon. We define Vs, which is the voltage source, and we defined L as L. Use the same variables. For example, if someone if I decided to define R as resistance, the whole word, so I have to use the same word here. You got my point? You have to define the variable and use the variable the same way that you defined it before. If you define it just R, you have to use R. If you define a whole word, a complete word, entire word like resistance, you have to use the variable the same way that you defined the variable before. Make sense? If even it is case sensitive, so what does it mean? It means that if you define r as lowercase r, you have to type it here as lowercase r as well. If you type r, lowercase r on the top, and here uppercase r, you're gonna end up with an error. You have to use the variable the same form, typically the same as you defined it before. If this is the force, it is Vs over L. So I used Vs over L, so it is Vs over L, the same variables. So try to stick or give names to the variables as you used to have them. Like tau, I wrote tau. Equals L over L, it is L over L. Make sense? So again, if I ask you to solve this equation analytically by hand, you're just gonna calculate tau, this is the first thing, then you're gonna calculate the f of t, the forcing term, then you're gonna plug them here to solve this equation, right? Now the third step is just solving the equation. To solve this equation, the function that would be used for solving the equation, first order ODE in MATLAB, is named dsolve function. But if you're gonna solve this one analytically, there are long of procedure that you have to do to solve this one analytically, as we explained before, right? But using dsolve in MATLAB, it is very shortcut. Like dsolve, this is the function name, and you're gonna open two parentheses, and you're gonna type some things here. The things that we type between these two parentheses or brackets, these are the options. What exactly? You have to tell MATLAB which equation that you would like to solve. Okay, I'd like to solve this equation for the current. So you have to type this equation first. You got it? You have to type this equation first. So let us use, for example, the variable CUR for current, or let us use I initially. So the first term in this equation, it is di by dt. It is the first derivative of the current. So to type the equation here, you have to use these two apostrophes, these two symbols. This is which is like the comma. عارفين حرف الطه في الكيبورد? Okay, so this is the apostrophe and this is another one. And between them, you're just gonna type the, so it should be in this purple color. It means that you're already typing equation. Okay, so the equation, it should be, I needed the first derivative, the first term is the first derivative of the current. So the first derivative is gonna be uppercase D, I. So I, this is the current variable, right? And uppercase D, this is the first derivative of I. How about if you need the second derivative, but we don't have a second derivative here. If you need second derivative, so it's gonna be D2I. So this is gonna be the second derivative of I. You got it? If you need third derivative, so it's gonna be D3I and so on. Here we just need one D, so it is DI directly. Don't type one. It is DI. It means that this is the first derivative of I plus 1 over tau. So I'm gonna open bracket 1 over tau. I define this tau as tau up there, times the current, which is I. There is no derivative to this current, right? So just I equals what? It should equal to the force, right? In the if the right side of this equation is constant or number or value, you can type it directly within this equation. But here we do have this forcing term as a function of time, as a function of another variable. So it should be written outside, like you have to move outside the apostrophe. Then you're just gonna have space and type the CHAR, which stands for character. And open two brackets and give the same variable that you already defined here before for the F, which is F. This is the forcing term. So why I didn't type this F? For example, it should equal to F according to this equation, right? This is acceptable as long as this F is value, not a function. But F itself, it is a function of the time. So if there is a function, we cannot plug this function inside the equation. It should be outside, and you have to use the character char open to parentheses f. Make sense? So this is the equation. You're already asking MATLAB to dissolve this equation. You got it? Type. So to solve this equation, we have to define some initial condition. This is ODE. For this ODE, there should be some initial condition, which is one initial condition that we need. Basically speaking, from mathematics, you had studied all of these things. You should have these things in mathematics. From the mathematics class, the initial condition, the number of the initial condition depends on the highest derivative of this equation. We do have here the first order derivative. So we need only one initial condition. If it is a second order derivative, if it is a second order ODE, we should have two initial conditions. So since we're already solving first order ODE, we just need one initial condition. So now we're gonna define this initial condition, which is I of 0. This is the current at t equals 0. This is like t equals 0. You got it? So the current at 0 equals how much? Equals I0, which is the initial condition that we defined before. Make sense? But again, that we have to use two apostrophes to the initial condition. So basically, the dsolve function, it works in this way, that you type the equation. In case that the forcing term is value, you can plug this value directly here. But if it is a function of time, it should be outside and I have to use character, right? And then you have to define the initial condition, then the semicolon, and that's it. So this is the dsolve function. Now, if I run the code, I should end up with a value for the current. Okay, so going back here to this command window. So the error, it is in line number 19. This is the error in line number 19, column number, forget about the column. It is line number 19, unexpected MATLAB expression. It means that the expression that I typed, it is wrong, which is this line number 19. It means there is something wrong in this expression. We're already using this thing as a variable. You have to add two square brackets. We have to confine the equation in a two square bracket, like this case. And now we can move this one on the top. You already, but for example, if I'm gonna type a number here and I won't gonna use the character F, in this case, remove the square brackets. You got it? But there should be square brackets in case that we're already using the character F. So that's why there was an error. Now if I run, I should be in a good shape. Initially, we're gonna type the equation, or the equation first. We're gonna type the equation di, which is the first derivative of I, which is this term, plus the 1 over tau, the current, times the current equals, and we should add number here, but we agreed that we're gonna add character F. In this case, you have to define F before the equation. Like if it is Vs over L, right? And we're gonna have the I of 0, which is the initial condition. It should equal to In, which stands for initial condition, right? And we defined here I0 as initial condition on the top. And as you can see, there is a variable, which is tau, is missing. That this tau, now we're gonna deal with this one like a variable like t. Okay? In addition, we should have I. So that's why I itself, it should be a variable. So that's why I was getting initially error. I was getting I equals negative I. It means that it is imaginary value, okay, which doesn't make sense. And there should be yes initial condition. Also, this initial condition in, it should be defined as a variable. Okay, then what we're gonna do, I'm just gonna type substitute. This is just to substitute value for the current. I already obtained a current here. So we're gonna solve like CUR equals. Forget about these things. So what we did, we defined tau. Initially, we defined tau. We defined the force term, right? Then we type the dsolve, and we wrote the equation, and we give initial condition, whatever it is. Like even we can type I0, the same initial condition, or IN. Now, if we run the code, we won't gonna end up with anything. Even if you try to type I as I was trying, I'm getting nothing. Why? Because you didn't assign the result of the dsolve function to a variable. So I'm gonna assign this one to current. To CUR stands for current. So I'm gonna say that current, which is CUR, I'm asking MATLAB to solve this equation and the result to be assigned to the current variable. So now if I run the code and try to type CUR the same way as you define it and press enter, you're gonna end up with the result. This is the equation. This is the solution of the first order ODE using MATLAB. But as you can see, this solution includes EXP, which is the exponential of the negative t divided by tau. It is in terms of tau and in terms of time. So now you have to substitute for the tau value, even it will be in terms of I0. Where is I0? Yeah, there is I0 here. So there are two variables that should be assigned value within this equation. You got my point? So the next step is just to type here the current equals the substitution within the current function that we got previously from this statement. We're gonna substitute for these two values, for the tau value and the initial condition value. Remove this one as R over L. We define tau as R over L and remove this one from here, right? And use IN, and this is I0, yes, and this is IN. So now if I run the code, I should be in a good shape. Okay, so I already got the current as a function of time. Make sense? So this is gonna be the code for a first order ODE. If you decided to run this code, so this is the current function. If we decided to change the value of R, your objective is just to change in the input section. If you have a different function for the VS, you can plug the new function. If you have different initial condition, you're gonna plug the new initial condition, the same thing for the L and the R. So your objective is just to change these variables. Make sense? Like for example, I can change this one into 15, this F into 10, and this force into 0. It means that there is no forcing term, and this initial condition into 1. So if you run, you're gonna end up with some current function, another one. So this is gonna be the current function as a function of time. Make sense? How about if you would like to plot? So this, you could consider that this is the input, this is the input section, this is the calculation, and this thing is the output. This is the output section. To represent an output in MATLAB as text, it is very simple. Just type the equation or remove the semicolon. I remove the semicolon. So it will be shown there. But if you added the semicolon, this current will not be represented in the command window. You have to type it there, right? Another way of representing the current, and this is what we are interested in since we are using MATLAB, is to represent this current or this function of the current over a graph, over a figure. So to represent this thing, you're gonna use figure, and you're gonna choose figure number, like number 1, number 2, whatever it is, number 2. Then you're gonna type EZ plot, because we're already plotting function. EZ plot, this is used, this command is used when you plot a function. And here we are interested in plotting this function, which is the current function that we already got. We're gonna plot this function within the range from 0 to 10, for example, like from 0 second to 10 seconds. So you're gonna see the function, how the current is changing within this time period from 0 to 10 seconds. If you run the code, you're gonna see a figure that is gonna be shown, and it's gonna give you how the current is going to change. This is the current. So for example, at t equals 0, the current tends to infinity, for example. And the as t equals, for example, at t equals 2, if you just intersect 2, move to the left, you're gonna end up with the current. So this vertical axis is the current, this horizontal axis is the time. Okay? So for example, if we give value for this VS, this is like 2, and we do have here 20, and we use this initial condition like 5, and run the code. So the current should be shown like wavy things. Do you see it looks wavy, right? Because of this forcing term. So let me increase this one, decrease this like 0 and increase this to 100. So as you can see, the current, it starts from 0. Then it increase, then decrease, increase and decrease and so on. So it has a wave, but this wave is going very fast, right? If you change this number, I'm going to change this number, which is the forcing frequency, to just 2. So the wave, it became longer. It will be wavy, yes, but longer thing. Like it won't gonna be narrow. It means that it is very slow. It changed, but slowly. Slower than the previous case. You got my point? So this is how we can represent or use MATLAB for coding and representing a figure. So this is the equation. We said that to set up the code, you have to split it into like 3 sections. One section is the inputs, the second section is the calculation part, and the third section is going to be just to represent the output, right? And we are interested in representing the output over a figure. So as we used to do at the last time, we have to start with clearing all the previous data from a previous run, also clear the command window because we're going to present some things over the command window, so we have to type the CLC. Then you can give a little bit of instruction as we discussed the last meeting about this code. So I could say that this code is for solving RLC circuits. Okay, then you just gonna start the first section, which is the inputs. We're gonna have here the input section. Inputs. In this input section, your objective is just to define some of the input parameters that we need, which should be given to you because we are interested in solving this equation in the current. It means that L, it should be given, R, it should be given, C, it should be given. The same thing for the VS, which is the voltage circuit. So to make it easy for you to not make the code more complicated, there is this way. You can just skip this L, R, and C and just start to define the VS. So I'm going to type the VS function that it should be given to us and assume that this VS function is already given as 10 times the cosine of 2 times t, which would be given as a function of time as already with any function, whatever it is. It should be like a function of t, and t, this stands for the time. So this is going to be, you can even put like an instruction here that this is the voltage source. Okay, and in addition to V, you should be given some initial conditions. Since we are already working or solving second order ODE, we should have 2 initial conditions. One for the I at 0, which is the current at t equals 0. So I'm going to call this one as I0, which stands for the current when t equals 0. This is like in this way. But so this I0, it should be given to us, assume that it is already given by 0. And in the meanwhile, you should be given the it or the derivative, the first derivative of the current when t equal to 0. So there are, since we are already solving second order ODE, you should be given 2 initial conditions. One initial condition is going to be the current itself when t equals 0. The second initial condition is the derivative of the current at t equals 0. So I'm going to call the derivative of the current. So it's going to be like di at t equals 0. You can give it a name the way that you want. And this current, it works like the velocity, because if you're differentiating anything with respect to the time, this is going to give us velocity term. Anyway, so this should be given with a value, let's say like 1, for example. So these 2 are initial conditions. So you could consider that this is the first initial condition, and this is going to be the second initial condition. Make sense? So that's enough for these things for the input for now. Now let us move to the calculation part. In the calculation part, your objective is just to type the equation, right? just to type the equation, which is this differential equation, whatever in the form of the xi and the omega n, or even you can use the L and R and C. You can even define, you can work with the xi, omega n, and if you are interested, or you can just use the L and R and C. Let us work with the xi and omega n because we are interested in studying the effect of RLC on this parameter of the electrical circuit. So to do so, I'm gonna type this equation. So the function that should be used, and remember that we are interested in solving this equation for the current. We do have a forcing term. The forcing term, it should be 1 over L times the time derivative of Vs with respect to the time, right? It should mean that it should be function of time. So for that reason, I'm gonna define F, which stands for the F, which is the forcing term. As already defined here, it should be 1 over L, where L it should be one of the inductance of the electrical circuit times the derivative. The derivative of any function on MATLAB, it should be def, which stands for the differentiation of Vs function that you just defined up there with respect to the time. You have to have comma t because probably we may have multiple variables here. So to which, with respect to which variable do you want to differentiate the Vs? Would like to differentiate, this is like dVs by dt, dVs by dt. So this d is the def, and the Vs comma t, it means that with respect to t. This is the physical meaning of this term. Make sense? So this is the forcing term. I define this term. Then simply we are interested in finding the current. So let us assume I stands for the current I, equal, then your objective is just to use the dsolve function as we did it for the in the previous meeting for the first order ODE, but here we're gonna type a second order ODE. How we can type this ODE? We said that we have to use the two apostrophes, these two, this symbol, and you just gonna type D2I, the first term here. It is the second derivative. The first term, this first term, it is the second derivative of the current with respect to the time, right? So what does it mean? The second derivative should be D2, the current, it is I. Make sense? Plus 2, this equation, there is 2 times xi. So I'm gonna define xi as xi times omega as om. So this om stands for omega, which is the natural frequency. This xi stands for the xi, or the xi variable that already existing here. Make sense? This times the first derivative of the current. So it's going to be just 1 di. So the derivative of the current is going to be di plus omega square. So it's going to be omega square. So it's going to be omega om square power to 2. This is how we can add power to any variable like omega, right? This times I equals, it should equal to the forcing term. We said that since the forcing term, it is a function of time, we have to use the character of f, this variable, and we have to add, don't forget the square brackets. You have to add the square brackets here. Okay, so this is the equation. We wrote this equation. This is how it's gonna look like, the equation on MATLAB code. Make sense? Then your objective is just to define. You're gonna type comma, then you're gonna write the initial conditions. We have 2 initial conditions here. In the previous meeting, we discussed only 1 initial condition. We had only 1. Why? Because we were solving only first order ODE. This is a second order ODE. You require 2 initial conditions. So the first initial condition, it should be the current of 0. It means that the current when t equals 0, it should equal to the initial condition 1. I'm just gonna type IN1 to stands for the initial condition number 1, comma, there is another initial condition, which is the D uppercase I of 0. This is the derivative of I with respect to the time. Okay, equals I initial 2, the second initial condition. So these are the 2 initial conditions, and this is how we can define the initial condition for a second order ODE. Here we do have I of 0, it means that this is the current when t equals 0, and the di of 0, it means that the derivative of the current when t equals 0 should equal to the second initial condition. Make sense? So this is gonna give us the current. If we run the code now, we're gonna end up with an equation for the current. But if we try to run the code at this instant, we're gonna end up with an error. Why? Because we have defined so many variables, and these variables were not assigned values yet. Like for example, the current, the xi, the omega, how much it is. MATLAB doesn't know at this instant, doesn't know how much are these values. Omega, how much it is. How much is I in 1 and I in 2, which is the first and the second initial condition. These values were not assigned in addition to the t. So you have to type in the input section. Once you write these equations, you're gonna type in the input section, symbolic. You're gonna define some symbolic parameters, which are the, including t. We do have the first parameter is t, is a variable. And we do have L, right? And definitely we're gonna have R and C. These are the parameter of the electrical circuits, okay? In addition, we're gonna have value for the xi, it is a variable, omega n, it is a variable, in addition to the I in 1 and I in 2. So all of these are different variables within the electrical circuit. Make sense? Now if I run the code, let me just save this one. So as you can see, one of the things, as we mentioned, when you try to save the MATLAB file, you have to use no spaces and no numbers. It means that it shouldn't start with a number. Like I have tried to save it like second. I'm starting with a number, so this is gonna give me an error. You should start with the letter, the file name. It should start with the letter and no space. So I'm gonna cancel this one and try to run again and save the file with a different name. Like for example, EM second. So it should start with a letter and no space. Okay, so now I run the code and the code run had been done. So if I type I, I'm gonna get the I function. This is the current function, but as you can see, the current, I obtained the current function as a function of xi and omega and I in 1, all these variables, even it is a function of time, all of these variables, just variables. I need to assign values to them. I need to give them values. So I would end up with the current only as a function of time. Then I can draw or plot this current. So the next step, your objective is just to type I equals the substitution. You have to substitute the current value. We do have the current function. I'm going to substitute these variables with I'm going to assign, kind of like you already assigning values to all of these variables. We do have the time, so we won't gonna substitute for the time. Why? Because we need the current as a function of the time. So we will not gonna substitute for the time, but we will substitute for L, for R, for C, in case that you used R and L and C in the above equation. And xi also we're gonna substitute with it for its value, and omega and the initial condition 1 and initial condition 2. So these are the variables. I'm gonna assign values to all of these variables. Make sense? Like for example, I can give value for L and R and C and xi, omega and initial condition and so on. So in initial condition 1, it should be I 0. Initial condition 2, it should be di 0. But how about xi and omega n, xi and omega r, l, r and c? So what I'm gonna do here, I'm gonna define L. You can even start with this one. I'm gonna type Rx, for example. Any other variable that is different than this R, then I'm gonna give it like 10 ohms. So this is gonna be the resistance. This is the resistance value. Also, I'm gonna do the same, like Cx, another different variable than the C that I have to use here. This one I'm gonna give it a number like, let's say 1 microfarad. So micro, it should be multiplied times 10 negative 6. 10 negative 6 in MATLAB, you can simply get it by E negative 6. So this 1 E negative 6, this is equivalent to 10 times power to the negative 6. So in MATLAB, if you are interested in exponent in a power, and instead of typing 10 to the power of negative 6, you can directly type E negative 6. So this is going to give us 1 E negative 6, which is like 1 microfarad. If we need it like 10 microfarad is going to be 10 E negative 6. If 3 E negative 6, this indicates that this is 3 microfarad and so on. So let us assume 1 microfarad of capacitance. So this is going to be the capacitance of the electrical circuit. Also, we're going to have Lx, which is the inductance. Let's say that it should be like 1 or 5 henries. So this is the inductance of the electrical circuit. Make sense? So these are the R. So for here, L, it should be Lx, value that you already defined up there. And R, it should be Rx, that you already defined up there. And C, it should be Cx, that you already defined up there. How about omega and Xi? Xi, as you remember, that we defined Xi as the half of R times the square root of L over C. So you can write this operation here, or you can use it in a separate line. So for example, it's gonna be much easier if I type like half times R times the square root in MATLAB, it should be square root, SQRT, of L over C. So this thing defined the Xi variable, how much it is in terms of R, L, and C. But R, it should be Rx, L, it should be Lx, and Cx, that you already defined them up there. Okay? For omega, the natural frequency should be the square root of 1 over CL. So it should be the natural frequency, which is omega, it should equal to the square root of the 1 over L times C. So then the last thing is just to type the initial condition. So we have here initial condition, which is I0, and the second initial condition I01. Make sense? So all of this, okay, it should be inside this square bracket. I0 and D I0, which is the first and the second initial conditions. Okay? So as you can see, I've wrote very long statement just to substitute with give assigned values to all of these variables. R and C, they were not included in the variable list here for this equation. But that is fine even if you just type them and you're gonna assign them values that you already defined up there. So, for example, in order to study the effect of R and C and L, your objective is just to change these variables, as I'm going to show you, these values. Okay? So now I assign values to all of these parameters, so I should end up with this current as a function of T only. Now I can plot or draw this current. If you would like to represent, so now we're going to move to the output. So this is the calculation section. Now we're going to move to the output section. This is going to be the output. If you are interested, for example, in representing the value of the current, or representing the current function, so I'm going to represent the current as I. This apostrophe here, you can use it, or you just going to type I equals I. Okay, so you're going to see when we run the code, as I'm going to do now, when we run the code, you're going to end up with I equals, and this is going to be the current function. It is a very long function because we substitute with the value. So it is a very long equation. You got my point? As you can see, there are some variables here like C and L. Still C and L. I should substitute by their values. So it means that you just typed them as C and L. It should be Lx and Cx as you defined them up there. Make sense? So now if I run the code, I should end up with the current only is a function of the time. There is nothing except T. So you aren't going to find in this equation except T. The other, it should be numbers. Okay? So this is the current function. Also, if you are interested of knowing how much is the Xi, the damping factor, how much it is, so you're going to type Xi equals, and the omega, the natural frequency omega equals, and so on. So which variable that you would like to represent, okay? Also, if we would like to represent this function as a plot over a figure, so I'm gonna recall a figure, let's say figure 1 or figure 2, whatever the figure number that you are interested in showing, and then you're gonna use the easy function or plot function on MATLAB to plot the current, which is I that you just got it up there, within the range between 0 to 2 seconds, for example, between 0 second to 2 seconds. So you are interested in representing how the current is going to change over time, okay, through this function. Then let us type hold on. Hold on, it means that you can add to this plot, add to this figure as you plot more, okay? Now the code is ready. If we run the code, we should, as you can see, when I presented this thing, I typed xi equals xi. So I got it as xi because xi, we didn't calculate it up there. But if you would like to calculate xi, it should be this term, this value, right? This should be xi, and omega should be the square root of 1 over Lx times Cx. This should be omega, right? And now we got, so we have to type this statement. This is just to convert, as you can see, like, because we already have here. So previously without the VBA function, without this function directly, if you type I, you're gonna end up with the current as very long statement that include lots of numbers, right? As you can see, we're gonna end up with very long statement. So MATLAB won't gonna able to deal with this lots of calculations because this equation includes some calculation. As you can see, there is division here. So I have to do all of this calculation first before going to the easy plot function. So that's why I'm gonna use this VBA, comma 4. So this comma 4, it means that I'm telling MATLAB to do all the calculation that included in the current function and approximate the numbers up to 4, all right? And then if you plot or run the code, we're gonna end up with the current and how it changes over the time. Make sense? Have these questions in the homework. Like you are already required to prepare a MATLAB code for a first order ODE. So you're gonna build a code like this one. And then you are required to build a code, MATLAB code for second order ODE. So you're gonna build another MATLAB code for the second order ODE. Okay? Once you have these codes ready, you can use them to study or do analysis to first order ODEs and second order ODE. So for example, you're gonna use the first order ODE MATLAB code to study the effect of the system resistance, which is R. If we change R, if we increase R from 10 ohms to 50 ohms, what's gonna happen to the current? Is it going to increase or decrease? But the current, it is a function of time and it is a wave function. A wave function, so what is exactly that is going to increase and decrease? Any wave to be fully described, let us assume a wave function. So we are expecting whatever you're already solving first order ODE or second order ODE for the current, as we discussed before, we are expecting that the current, it should be in this form. This is gonna be the current as a function of time, and this is gonna be the time. So we are expecting the current in case we start with 0 initial condition, so we're gonna start from 0. In case that I of 0 equals 0, we're gonna start from here. But in case that I of 0 is with a value, so we're gonna start from that value, okay? From 0, you're gonna end up with the current. So the current will be increasing, then it's going to decrease. So it's gonna take this wave function, right? Kind of. Then it would be decaying after that. So there are lots of things that we can study for this current. One of the things is the wavelength. The wavelength, which is this distance. This is lambda, for example, or the wavelength. Also the frequency. We said that this current, it has a certain frequency, but this one has a higher frequency. So if the wave ends very fast, it means that this is the first wave, takes short time, but the time for the red wave, it is bigger. So it means that this red wave, it has a frequency. For example, let us assume the frequency of the red wave by omega 1. Assume that this is omega 1 or omega n1. This is the natural frequency. And the natural frequency for the second wave is omega n2. So for this case, omega n2, it is bigger than omega n1. Make sense? Also, as you can see, the wavelength, this wavelength, this one, it is that lambda 1, which is the wavelength of the red wave, but the wavelength for the brown wave, it is lambda 2. As you can see, lambda 1, it is bigger than lambda 2. So all the time the wavelengths and the frequencies, they do have reversed relation, or they proportionally, or the natural frequency is proportionally related to the inverse of the wavelength. Okay, so this is, for example, these parameters. This is the thing that you have to discuss. It is required here to discuss the effect of the system resistance on the amplitude, and I'm gonna let you know what does it mean, the amplitude, the frequency, which is the omega n, and the period, which is this wavelength. Also the wavelength is related to the period, which is the periodic time. This periodic time, it should be this time value, this time distance. How much is this t? The red one, for example, takes longer period than the brown one. Okay, the amplitude, it should be the maximum height. It should be the amplitude of this wave. This is the amplitude. So now it is required to study the effect of R. If we change R value for C equals 10 microfarad and L equals 0 for a first order ODE, and the Vs equals 10 cosine 2t. This is the voltage, the voltage source. And the initial condition is 0. What is the effect of the resistance on the amplitude, the frequency, and the period? Three things. So to do so, you're gonna use the MatLab code, the first order ODE. First, you're gonna put t equals 10, the first value. We would have the first value for the resistance, it is 10 microfarad for the capacitance, and L equals 0. So in the code of the first order ODE, you're gonna put this one as 10 microfarad. So that's why I multiply times 10 negative 6, which is 1e negative 6, and this is 10, and this it should be L, which is Lx. And this is the voltage function, and the initial condition it is 0. In the first order ODE, we need only one initial condition. Then you're gonna run the code. When you run the code, you're gonna end up with a figure like this one. Okay, if you open, let me close these things just to show you how we can edit to this figure. So if you just open and go to view, and you're gonna find here property editor, you're gonna press on this one, you're gonna find this editor. It is better to put this one blue down here. Okay, this editor, through this window, you can edit anything to this figure. Even you can add here the horizontal axis, which is t, the time. I need to type over the vertical axis the current. So the y-axis, it should be the current. So you can type here the current as I of t, right? And over the x-axis, it should be t. So this is like the current on the vertical axis, and this is the time, and this is how the current is going to change over time. As you can see, it gives us sine wave, right? Or a certain wave. If you just also press on view plot browser, this one, you're gonna end up with some list of curves. So let us just use one curve, which is the last one. So this is the curve that we obtained. If you just press on this one, you can give it a value. So the value here of the resistance, it should be 10 ohms. It should be 10 ohms. Ohm, it has a symbol, MATLAB symbol like ohm. We can type this one in this form, but there is no need even to know these symbols. If you just type R equals 10, then if you go to the figure and right click, you're gonna find show legend. If you pressed on this one, you're gonna find R. So what does it mean? It means that this curve, for the case that R equals 10, then you're gonna return back again to the code and it change this R to be 20, the next value. We already changing, we have to change the R. 10, 20, 30, 40, and 50 for the same values for the other variables. It means that the C will be still the same, L, VS, I0. The only thing that is going to change is R. And run one more time. So we're gonna end up over the same figure with another figure, which is the new one. This is another figure already shown here. This figure, it should belong for the case R equals 20, right? Then you're gonna repeat again, go back again to the code and make it 30 and run the code. So we're gonna end up with a third figure. This it should be for R equals 30 and so on up to R equals 50 and run the code. So we're gonna end up with multiple figures, but as you can see, all the figures, they already considered. What does it mean considered? It means that we already ending up with the same figure no matter what is the value of R. As we change R, nothing happens, no changes to the curve. We're still obtaining the same curve as we change R. So what does it mean? It means that the resistance for a first order ODE for this, what is the type of this electrical circuit? Anyone? This is RC circuit, right? Because there is no inductance here. So for this RC circuit, as we change the resistance will not affect the obtained current. It means that the current somehow does not depend on the resistance. Okay, it do depend on the resistance in the magnitude value. The magnitude of the current, the height, this height, if we just show the grid, this height from the zero level, let me just increase the font. You can even play with the setup if you just press on export setup, but you have to press outside here. Click here and export setup. You can increase the font just to make things clear to you and increase the line thickness, for example, to 3. Okay. So as you can see, as much as we increase the resistance, we're still getting the same curve. So what does it mean? It means that the resistance will not affect the wave, the natural frequency, it will not affect the wavelengths, it will not affect the period, right? Also, it will not affect the amplitude. We're still getting the same amplitude, which is this vertical distance. It is still the same, okay? The period is still the same. The current is, the natural frequency is still the same. So there is no changes within these variables as we change the current, the resistance. Make sense? As we change the resistance, there is no change in the current in terms of frequency, in terms of amplitude, in terms of the period and the wavelength. But this does not mean that the current do depend on the resistance. No, it do depend on the resistance, and the resistance is the value that defines or it affects the shape of this wave. You got my point? It is related. So the current depends on the resistance somehow, but the effect of the resistance in comparison to the effect of the other variable within this RC circuit, it is very negligible. So that's why we didn't see any changes in the amplitude or the resistance or, the frequency or the period. Make sense? But for the second case, if we fix the R value to 10 ohms and L to 0 and VS to this function and initial condition to 0, but we did it change only to C, we're gonna end up with different curves, as I'm gonna show you. So now what we're gonna do, let me remove all of these curves. So this is gonna be one figure. You're gonna save this figure from here. Just file, save. This figure, this is gonna be for the first part. Make sense? So I can simply save this file and you're gonna save it to your desktop somewhere for the resistance for the first part. Now let us move to the second part. I'm gonna remove these curves and I'm gonna work for the second part. I'm gonna fix this one to 10, then I'm going to change this Cx from 0.1 up to 100, and this is 0 and the rest is gonna be the same. So when C equals 0.1, we're gonna end up with a curve. So this curve, you can even increase the thickness of the curve. Select the curve and increase the thickness from here. This is the line thickness, make it 3 for example, so it's gonna be clear. This curve, it is for C equals 0.1. Then we're gonna run one more time, for example, for C equals 1. So we're gonna end up with a different curve, as you can see, right? This curve, the new curve that we got, this indicates that C, it has a significant effect on the current. C affects the current. In terms of what? What is the difference? This wave, the green one, was for the case. Let me just change this one to red, for example. So the green curve was for the case that C was 0.1. For the case C equals 1, we're gonna end up with a different curve with a higher amplitude. So as we increase C, the amplitude is going to increase. This is the first difference, or the first effect. So what is the effect of C over the amplitude? As we increase C, which is the capacitance of the electrical circuit, the amplitude is going to increase. Make sense? How about the wavelength? How about the wavelength? The wavelength, as you can observe, is still the same. Why? This 0 point, if you just go through the wave, you're gonna end up also with another 0 on the other side. It means that the wavelengths for the green curve and the red curve, they do have the same wavelengths. This indicates that they do have the same frequency, they do have the same period. So the period and the frequency are the same. It will not be affected by the capacitance, but the capacitance will affect only the amplitude of the wave. Make sense? Okay? But if we just make it 10, for example, we're gonna end up with another amplitude in this way. So the amplitude is going to increase, but we still having the same wavelength and the time period. You got it? So this is for first order ODE. You're gonna do the same for a second order ODE by changing R, fixing C. If you try for the second order ODE, L equals 0, I bought L equals 0 by mistake in the homework. Okay, so try for the homework, but L equals 1, so you're gonna end up with the results. Because if you put it 0, you're gonna end up with an error. For the homework, for the second order ODE, this L, it should be 1 henries, not 0. The same thing for the second point. Make sense? So for example, if I run the second order ODE to study the effect of C, this is the second order ODE, I'm gonna fix R to 10, I'm gonna change this one from 0.1, and this I'm gonna fix LX to 0. Then I'm gonna run the code. So we're gonna end up with a curve like this one, this curve. Just let me squeeze this distance to be just 1. Okay. Let me double check the values here. It should be 10, and it is 10 microfarad. This is 10, this is 1, right? This is 2. And 2, 2, and 0. Just make this one 1. Okay. So your objective is just to observe the difference. in what? In two things. For example, if I decrease this distance here, let's say up to 0.1 or 0.1. Okay. So as you can see, the wave starts with a high amplitude and then decreasing. The amplitude decreases as we move with the time. This indicates that we do have a damping effect. There is a damping effect, and this is what we discussed in the second order ODE. Okay. So what's going to happen as we change C? If we try to change C value to 10, we increase C. What's going to happen to the decaying and the amplitude of the wave? As you can see, we're gonna have almost coincident, but the purple one, which is this thick curve, this curve, it has a bigger period, bigger wavelength. It means that the frequency decreases. The natural frequency decreases as we increase C. And this makes sense as we already defined here. We defined C. As we increase C, as you increase the C value, we are expecting that this frequency is going to decrease. As we increase C, we are expecting that the damping factor is going to decrease as well. And this is very clear in this case. In this curve, we're already having the frequency, the period, the gap between one wave and the next one is increasing. This indicates that the period is increasing, the wavelength is increasing. So also this indicates that the natural frequency is going to decrease. Also, as the increase in the period indicates that we're gonna have a decrease in the damping factor. So what is the effect of C over the damping factor, the natural frequency, the period, and the wavelengths? The wavelengths increases, the period increases, the frequency decreases, the damping factor decreases. The amplitude is decreasing as well. All of this is the effect of C. Make sense? If you did the same, if you just try to play and change the value of L and fix the other value and observe the changes to the wavelengths, to the period, to the damping factor, all of these parameters, you can understand what's gonna happen up on changing these variables. Okay, and this is the objective of this homework, I'm sorry.